Hello students, I am Farida and today we are going to discuss 8.4 topic electric potential due to point charge. Now let us consider here a point charge. At position O, this is Q point charge and there is an electric field due to this charge. Now let us consider another point here, A, situated at distance r from the point charge. We need to determine the potential of the charge at point A, and it is at distance r from it. Electric potential at point A is the amount of work done per unit positive charge, isn't it? Work done per unit positive charge is nothing but potential energy, correct? Here potential energy, that is equals to work done upon charge. Now to displace the charge from infinity to A, whatever work is done, that is converted into the potential energy. We know the work done is independent of the path. We choose a convenient path along the line exceeding this A line to infinity. Now let us consider one point M here. It is an intermediate point on this path where we can consider OM, that is equals to X. OM is equals to X. Now the electrostatic force on a unit positive charge. Now suppose we are putting this unit positive charge here. So the electrostatic force on this unit positive charge, which is directed in this direction, in magnitude, that is given as F is equals to whatever is the force experienced by this charge, that is the electrostatic force, correct? And that is given in magnitude, that is equals to 1 upon 4 pi epsilon 0, by which charge the force is there? Due to this Q charge. And what is the distance between them? That square of distance we are taking. So because this Q0 charge is unit charge, so we will not write here on the in product. So it is here, it should be here like, but we are not writing because the magnitude we are considering as 1. So F will become here. Finally we can write here 4 pi epsilon 0, that is Q upon X square, the distance, square of distance between them. This is our equation number 1. Now let us consider we are displacing this Q0 charge from this M position to N position somewhere here. So this displacement is given as dx. We are applying some force opposite to the electrostatic force to displace this Q charge from M to N. And so the work is done. Work is done because we are applying the force opposite to the electrostatic force. The direction of electrostatic force is here, and we are applying the force to move the charge from M to N. So this is the applied force. This is the direction of the applied force. And what is the displacement? Dx is the displacement. So we can write the small work is done over there. Okay, whenever we are applying the force and that time the displacement takes place, then we can say there is a work done. So that work done we can write in minus F into dx. Now why minus F into dx? That we can mathematically prove here. The dW, the amount of work done, is equals to force, electrostatic force into displacement dx, and that is equals to, now here this is the force, electrostatic force that we are taking, and the displacement is in opposite nature, opposite to this. So into dx we are taking, what is the angle between them? The force, electrostatic force and displacement, there is a 180 angle. So cos angle between them we will take. So dot product we are taking. So F into dx, that cos 180 we can write here now. So this becomes now F into dx, and cos 180 is nothing but 1 minus 1, sorry, and so dw becomes here, if you multiply and take the value, then it will be minus F into dx. So in this way mathematically it is proved that dw is equals to whatever work is done, that is minus. So this equation we have written here, and this is, let us consider this is a second equation. Now in this equation we are putting this value of F from equation 1. So we will get here dW is equals to minus F. F is nothing but 1 upon 4 pi epsilon 0 and Q upon x square. This is the value of F I am putting, and into dx as it is I'll write. But this is the work done when we are moving this charge from M to N. When the small displacement occur here, that is dx. But if I want to put this charge from this position, infinite position, to A, then what will be the work done? That is called the total work done. And total work done is nothing but we are shifting this, if I am considering or moving this charge from this to this place, dx displacement will be occur, again dx, again dx, again dx. In this way total dx I am calculating together or adding together or integrating together, then I'll get the total work done, and that total work done I'll write as W, and that is nothing but integration of dW. But from where to where? I am taking that charge from infinity to R position, from here to here. Okay, this much distance is we are considering, up to A is R. So infinite to R. Then I'll write here the value of dW, the magnitude of dW here, and I'll write here that is equals to minus 1 upon 4 pi epsilon 0 Q by x square into dx. Okay, so going next we will write here this thing again, that is W is equals to, now the whole thing which is constant term here, that I am taking out of the integration sign. What is constant here? This whole thing is constant. Charge is not changing, so whole thing is constant. So that I am taking now here 1 upon minus sign will be there, 1 upon 4 pi epsilon 0. Let us see again, q upon x square. So only q I'll take out. So here I'll take q out of this, and in integration sign again infinity to r I'll write 1 upon x square into dx. But integration of 1 upon x square, and that is also written as for our convenience, I'll write here q upon 4 pi epsilon 0 from this infinity to r, and that is x raised to minus 2 into dx. Can we write like this? For 1 upon x raised to 2 can be written as like this. But we know this integration of x raised to minus 2 into dx will be 1 minus 1 upon x, correct? So this value we will put in this equation, above equation. So w will get here the total work done, and that is equals to minus q upon 4 pi epsilon 0. Okay, and integration, now we are solving this, so square bracket we will write. So whatever value we will of this integration of x raised to minus 2 dx, that I am putting as 1 upon x minus 1 upon x, but the limits I'll put as it is here. The lower limit is infinite, and this, so I'll write. So w is equals to minus q upon 4 pi epsilon 0. Now how to solve this? When the limit we are putting, then we will put as it is minus sign, and wherever x is there we'll put the upper limit first, that is r. In formula minus sign is there, that I'll put. This minus sign I'll put here. 1 upon wherever x is there, now lower limit will put, and in this way the bracket closed. So w is equals to minus q upon 4 pi epsilon 0. This is minus 1 upon r, and this whole thing becomes, whether it is positive or negative, this 1 upon infinity becomes 0. So here we'll write now minus q upon 4 pi epsilon 0, and this value is minus 1 upon r only. This whole thing becomes 0. So minus minus becomes plus. So now w is equals to q upon 4 pi epsilon 0 r. This will be the last equation for work done. But remember, the work done, we'll write and we'll go ahead and we'll say the work done then is converted into potential. So the work done is w, potential is v, and what is the value of this w? That will write q upon 4 pi epsilon 0 r, q upon 4 pi epsilon 0 r. So now that's why we can say the potential at point r due to the charge q is q upon 4 pi epsilon 0 r when the charge is kept in vacuum. Okay, and let us discuss one more thing, case in that r is equals to taken infinity. Let us consider the point charge is at infinite level, or that test charge is at unit charge is at infinite level. So what is the potential at that point? So we'll write here r's value. So v is equals to q upon 4 pi epsilon 0, and this is infinite. So we'll write here anything divided by infinity is 0, so v becomes 0. So we can say that at infinity, if we'll see, the potential will be 0. Potential will be 0 at infinity. Okay, so we can write here, this shows that the electrostatic potential is 0 at infinity. Okay, so in this way we got the equation when we'll say here the electric potential. Okay, electric potential we got due to a point charge, and that value is equals to V is equals to Q upon 4 pi epsilon 0 R. Now let us stop here in this lecture, and we'll try to take a new topic in the same 8.4, that is electric potential due to electric dipole, in the next lecture. Till that time, have a good day. Thank you.